Hey, what's going on, guys? In this video we are going to see how to find out the Laplace transform of y double prime plus 4y is equal to t, and we have the initial condition given y of 0 is equal to 1 and also y prime of 0 is equal to 2. Okay, first of all we have to know the Laplace transform of second derivative y double prime and y. These two things we have to know. When we do the Laplace transform of y double prime, that will end up with s square y of s, and if you don't know how did we derive this one, you can watch my previous videos. I have explained how to derive the Laplace transform of y double prime, y, and also t. Okay, here we have s square, this will become s square ys, and we will have minus s times y of 0. Y of 0 is 1, so I just directly put the value, minus y prime of 0, that's going to be just 2 right here, and we have taken care of this part alone right now. Okay, this whole thing is only for y double prime. The next thing is we have to take care of this 4y. 4y is basically, if you do the Laplace transform, that's going to be basically 4 times y of s. Okay, that's it. And in the other side we have t. If the Laplace transform of t is basically 1 over s square, because t power is 1, it means 1 over 1 factorial over s power 1 plus 1, so that's going to be 1 over s square. Okay, now we have found out that Laplace transform. Now the next thing is we have to combine all the y of s terms. If you combine, here we have s square right here, and here we have 4, so s square plus 4 y of s, and other terms I'm going to bring to the other side. First we have 1 over s square right here, and if I bring this s to the other side, that's going to be plus s, and if I bring this 2 to the other side, that's gonna be plus 2, and that's it, plus 2 and plus s. Now to bring the same denominator, what we can do is we can multiply this one by s square and divide this one by s square, and we can do the same thing for this one as well, 2s square over s square. In that way we can add them together, and if we add them together, this is gonna be just s square over s cube. This one is s cube, plus here we have 2s square plus 1, and y of s, here we have s square plus 4. If I bring to the other side, that's going to be in the denominator, so s square plus 4 in the denominator, like this. Now here, to solve this one, we have to use the partial fraction decomposition. In partial fraction decomposition, if we separate this one, this is going to end up like this: s cube plus 2s square plus 1 over s square times s square plus 4. And if we separate this one, this is going to be a over s plus b over s square plus cs plus d over s square plus 4. Okay, this s square repeats 2 times, because when you have square you have to repeat twice. If you have cube, you have to repeat this one 3 times. It goes like that. Okay, and here we have a linear because we have a quadratic formula, that's why we have a linear, and this would be also quadratic. Like, you can also write this one as like this: as plus b, if you write it in a quadratic alone, s square, and then this will become cs plus d over s square plus 4. And here if you separate this one, as over s square, you will get a over s like this, and if you separate b over s square, that's going to be like this. So both way it will work. We can directly put it like this. Okay, let's go ahead and continue. Now here we can simply find out this b, because we have s square here and b has s square. Think it like, if you multiply this whole thing by s square, this denominator square and this one cancels each other, so we just have to eliminate all the other s and solve for b. To eliminate other s, what you can do is equate s is equal to 0. So if you equate s is equal to 0, this one will be cancelled, this one will be cancelled, this one will be cancelled. Here we have 1 and 4. This s square is already gone because it's cancelled with the denominator, so 1 over 4 remains. So from this one we can directly find b is equal to 1 over 4. You can also do it in a long method, like compare coefficient and stuff, but this is a better way to do. Since we have the denominator and here we have the same thing, we can just get rid of that and make other s's 0 and solve for b directly. So this is 1 over 4. Now let's go ahead and find out other things. Here we have s cube plus 2s square plus 1 in the numerator, and in the other side we have a over s plus b over s square plus cs d over s square plus 4. So what we are going to do is we are going to multiply this whole thing in the other side. Okay, if you multiply the whole thing in the other side, this is multiply the whole thing by s square plus 4. So if you bring it and multiply the other side, this doesn't exist in this side anymore, so that's why we have this one alone in this side. And in the other side, if you multiply it by this one, here the denominator s will cancel with one of the square, so this is going to be just as times s square plus 4. Okay, that's for the first one. And then we already know the b, that is 1 over 4, and s square already cancels because this s square and this s square cancels. We will have s square plus 4. Here we will have s square plus 4 right here. And then if you multiply by this one, s square plus 4 cancels, so we will have cs plus d multiplied by s square alone. Okay, now the next thing is we are going to expand this one, all of these things. As times s square, that's going to be as cube, plus as times 4, that's going to be 4as, plus 1 over 4 times s square, that's going to be 1 over 4 s square. 1 over 4 times 4, that's going to be just 1. And then next thing is cs times s square, that's going to be cs cube. And the next thing is d times s square, that's going to be ds square. Okay, in the other side we have s cube plus 2s square plus 1 right here. Okay, now if we look at s cube alone, s cube has coefficient 1, so let's write it here. Now we are comparing s cube coefficients. Okay, s cube has 1 in front of here, so 1 is equivalent to, in the other side we have, in front of s cube we have a right here, and also we have c right here, so a plus c. And in front of s square we have 2 right here, 1 over 4 right here, and d right here. So this is going to, if we compare s square, that's going to be 2 is equivalent to 1 over 4 plus d, 1 over 4 plus d. And the next thing is we have constants. Here we have 1 right here, and here we have 4a, and s is 0 because we don't have any s. So if we compare s, that is 0 right here, and that is equivalent to 4a right here, and we don't have any s, so 4a is equal to 0. And if you compare the constants, here we have 1 in the other side, and in the other side we have 1 is equal to 1, so we don't have to worry about it because this is not involved with a, b, c, anything. We already know b from the first solve. We solved for b here, that is 1 over 4. Let's note that one down right here. From this one we know that a is equal to 0, and from this one we can directly find out the b, actually d. If you bring this 1 over 4 here to 1 over 4 here, 1 over 4 and 2 minus 1 over 4. 2 also can be written as 8 over 4. So 8 over 4 minus 1 over 4, that's going to be 7 over 4. So d is equal to 7 over 4. And here we have a is already, we know that 0, so this one doesn't exist. So from this one we know that c is equal to 1. We have a 0, b here, c here, d here, so we can find out the Laplace inverse right now. Let me use a different color. Okay, here this is the one we are going to use. Okay, here we are going to plug everything. A over s, a is 0, so we don't have to worry about that one. B is 1 over b, we found b is 1 over 4. So let me separate this one. B is 1 over 4, and then s square, 1 over 4 s square, and then we have cs plus c is what? C is 1, so s over s square plus 4. Then d, I separate this one into two parts like d, c and d. D is going to be 7 over 4 times, let's think it as 7 over 4 times 1 over s square plus 4. Okay, now here we have to find out the Laplace inverse of this one. Okay, let's take the Laplace inverse. If we take the Laplace inverse, that's going to give us y of t. So let's do it individually. Here we can take the 1 over, okay, here I made a mistake, this s square is in the denominator, so 1 over s square, 1 over 4 Laplace inverse of 1 over s square plus Laplace inverse of s over s square plus 4 plus 7 over 4 Laplace inverse of, here we can, instead of s square plus 4, we can write it as 2 square. So 1 over s square plus 2 square. And here if I multiply by because here we have b square right here, to make this one same to the numerator, we have to put a b. So 2 right here, and also we have to divide this one by 2. Okay. And in that way we will get 7 over 8. Okay, let's go ahead and complete this one. 1 over 4 1 over s square. If you take the Laplace inverse of 1 over s square, that's going to be just t. And Laplace inverse of s over s square plus 4, that's going to be just cos 2t, because b is 2 right here, so this is going to be cos 2t plus 7 over 8 Laplace inverse of 2 over s square plus 2 square, that's going to be sin 2t. Okay, that's it. That's the Laplace inverse of this whole thing. This is our y of t, and that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.